In this video, we want to talk about polar equations of conics. Now, before we can really jump into that, I want to make sure that we have some ground rules established. So when I see capital D, that's going to be the directrix, F is going to be a focus, and this lowercase e is eccentricity. Now, I know in the past we've seen E as being, Euler's constant, but here it's not going to be that. It's going to be representing eccentricity. And E will be defined as the ratio of the distance between a focus and a point that's on the graph over distance between the directrix and a point on the graph. So capital P is just going to be the collection of all points that make up your conic section. We're going to be focusing on parabolas, ellipses, and hyperbolas. And so the value of E kind of tells us, what kind of shape we're going to have. Now we're going to talk about the actual, equations here in just a second. But here's what we're going to be looking for when it comes to the E. So when E is equal to 1, that means we're talking about a parabola. When E is something less than 1, we're talking about an ellipse. And when E is greater than 1, then we have a hyperbola. Right? So as long as we keep this in mind, we're really going to be fine. Now, one of the ways to kind of make sense of this is if you think about a circle, okay, and you just have your center right there. It's almost like you have your focus right there. We call it the center. The center and the focus is kind of all the same when it comes to a circle. Now, if you start to take that point and you start to kind of split that up, you start to stretch the shape out, and it becomes more elongated, and it becomes an ellipse. Now, if you then keep stretching and stretching and stretching, then the ellipse becomes a parabola, because you kind of lose half of it based on how the E value works, and you keep going and going, and you end up getting the hyperbola out of that. So there are 4 main equations that we're going to be looking at when it comes to these conic sections written as a polar equation. They're all pretty much the same. It's a matter of understanding the orientation of your graph. And these are all based on having a focus at the origin. So for all of these, the focus is going to be at the origin. So if I say R is equal to the product of EP over 1 minus E cosine theta. So in this form, D is going to be perpendicular to the polar axis, and it's going to be P units to the left of the origin. All right, so that's when you have EP over 1 minus E cosine of theta. Something very similar to this is if I do EP over 1 plus E times cosine of theta. It's pretty much going to be the same thing, where the directrix is going to be perpendicular to the polar axis. So D is going to be perpendicular, and then it's going to be P units to the right. Now, an easy way to kind of, keep track of this is that when it's a minus, this guy's going to the left. And if it's a plus, then that directrix is going to be P units to the right side of the origin. And then we have two other forms. Again, it's not going to be that much different from what you see here. It's going to be in terms of sine now. And really the difference between cosine and sine will be how the directrix is oriented with respect to the polar axis. So if I have EP over 1 minus E to the times sine of theta, your directrix is going to be parallel to the polar axis, and it's going to be P units below. And so the P units below, you can kind of see that with the minus there, kind of connect that with being below. And then finally, if we have R is equal to EP over 1 plus E times sine of theta, again, D is going to be parallel, and it's going to be P units above. So the plus right there means we're going to be going above. So as long as we keep all this information straight, we're going to be fine. So with cosine, connect that with being x. So that means we're going to be moving our directrix P units to the left or to the right in the x direction, right? And so if you can think about it moving the directrix left or right like this, that means it's going to be perpendicular to the polar axis, which of course is that ray going from the origin going out in the positive x direction. Sine, you think about that in terms of y. And so think about moving your directrix up and down. So that's going to change things. A minus is going to move it below the polar axis. Plus is going to move it above. Yeah, and so you think about this sine as in terms of y. And if you have just like y equals, that gives you that horizontal line. So you kind of make those connections, and that should make things pretty simple in terms of figuring it out. When we're working these, there are going to be some key values that we want to plug in so we can get a really good idea about the shape. So when we're working with cosine, you want to use 0 and pi. And really, we're probably going to use like 0, pi, and we'll probably also do pi over 2 and 3 pi over 2. But really, 0 and pi will give us some of our key values, just because that's when cosine is going to give you either 1 or negative 1. So you kind of plot those points and get a good idea about the starting points and the starting shape of your graph. And if we're talking about using sine, we'll be focusing on using pi over 2 and 3 pi over 2. All right, so now that we have this all written down, let's start working through some examples. So we'll do that in just a moment.